Hello everyone. Should we start, Rashmi, Alka? Are you here? Okay, thank you, Alka. So let's start. This is the week 12, and I think one class I will take tomorrow. That will be extra class. If you will have any kind of doubt, you can tell me. I can cover that particular topic in that tomorrow's class. And today is the second last class. And again, the timing will be the same, 6 to 8 p.m. And but the last class will be on Tuesday. That is tomorrow from 6 to 8 only. So I'm T. Jyoti Sharma, and this is my quick introduction that I'm a PhD student right now from ISO Bhopal. And because I'm a PMRF student, so I have the liability and the responsibility to teach and to have this live session for 2 hours. So and again, this is the end of the live sessions. So there is no any requirement to tell it, but yes, your communication or your discussion is highly encouraged. So you are encouraged to speak, or you can also write in the chat box, and so your participation is highly valued, right? Okay, so we have week 12. Actually, I wrote here week 11. So we have week 12, and in that week 12, uh, we will uh, we will have 5 lectures. The first lecture will be on the sampling and analysis of particulate matter 2.5. So how do we can measure particulate matter 2.5? We will talk about that. What different technology, what different methodology we have to measure sulfur dioxide and nitrogen dioxide. We will talk about it. Then if the gas or the particulate matter are being emitted from the stacks or from the chimney, so how can you measure that? So we will talk about that. Then there is some instrument that we can explore to get the concentration at your house, or so we can say that to know the quantity of the particulate matter that is present in your indoor, so we can also estimate it using some instrument. We will talk about that. And yes, in spite of the chemical method, we have different method to calculate this particulate matter, and some even sulfur dioxide and nitrogen dioxide, even using some machine through which, like within a minute or within a second, we can have these values. So we will talk about that as well. So initially, I have the previous year assignment question. We will solve it, and then we will start with the lecture wise. So topic wise. So topic wise, we will try to solve the questions. So okay. So my first question is about the particulate matter 2.5, because we will talk about how we can measure this particulate matter 2.5. So before that, you must know what should be the standard, like what should be the threshold above which we should not exceed it, right? What should be the value of this particulate matter according to NAAQ is 424 hours, and in industrial, residential, rural, and other areas. Alka gave me B answer, that is 60 microgram per meter cube. The threshold value to above to that we can't exceed. Anyone else? Rashmi also gave me B answer. Mohammed Abdul, yes. Will you also try to answer it? What is the permissible value of the particulate matter 2.5, and above which there will be the negative impact? Okay, you also gave me B answer. Okay, so yes, answer is B, that is 60 microgram per meter cube. My next question is for the particulate matter 2.5, while we are doing measurement of it, we need a filter paper, and that filter paper is made up of a chemical. Okay, and you have to tell me the full form of that chemical. We use that PTFE. This is the material of which we have the filter paper. So you have to tell me what type of what type of material we are talking about. Okay, Muhammad gave me C answer. Alka C, A C. Uh, okay, so you are talking that answer should be polytetrafluoroethylene. Okay, so yes, answer is C. This material is PTFE, and that is polytetrafluoroethylene. Okay, next question is you have to identify the gas that is colorless, and the smell of it is just like the matchstick like smell, the burnt matchstick like smell. Okay, most of you gave me B answer and AS gave me A answer. Okay, the answer should be B only, the sulfur dioxide. This is the gas that is colorless. No doubt, carbon monoxide also the colorless gas, but it will not give you the smell. But sulfur dioxide will give you the burnt matchstick type smell, and because of that reason, carbon monoxide is a silent killer. The reason is only that because it is colorless, you will not have the smell of it. Okay, and that's why this is the silent killer. So carbon monoxide should not be the answer. In spite of that, the sulfur dioxide should be the right answer. So B will be the right answer. Okay, again, I want to ask you the permissible value of the sulfur dioxide, and but here this is in ecological sensitive areas, and this is for annual. So, what should be the annual concentration of sulfur dioxide in ecological sensitive areas? Or an AAQS. Korea gave me B answer. Abdul also gave me B answer. 20. Any other answer? Rashmi gave me 20 microgram per meter cube. Yes, Alka. Okay, Alka gave me B answer. Okay, so answer is B. So the permissible value for this sulfur dioxide annually and in ecological sensitive area is 20 microgram per meter cube. Okay, which of the following is used for optical reference in the spectrophotometer? Reagent blank, then distilled water, sample, tap water. Rashmi B, Alka B, Abdul B, Korea B, AS B, Alka distilled. Okay, yes. Yes. So the answer should be B only. So we do use distilled water for optical reference and in the spectrophotometer. Okay. Here we do a sampling in such a way that the velocity that is at the chimney will be equal to the velocity at our sampling nozzle, sample nozzle. So this technique will be known as what? So sampling at such a rate that the velocity and direction of the gas entering the sampling nozzle is same as that of the gas in the duct or stack at the same sampling point is known as. Okay, B, Abdul B, Korea B, ASP, Alka isokinetics means B. Yes, so this technique is known as isokinetic, and if you know that it is a uh, kinetic. Kinetic means the direction and the velocity. So there is a velocity that is the important parameter in this isokinetic, and the velocity that is within that chimney should be equal to at our sampling nozzle, so that the sampling that we are doing can match with the true representative stack gas. So that's why we do use such kind of technique, and that is known as the isokinetic sampling. So B is the right answer. Okay, so there are few statements regarding this isokinetic sampling, and you have to tell me which statement is right. So I have four options. The kinetic energy of the gas stream in the stack should be greater than the kinetic energy of the gas stream through the sampling nozzle. The kinetic energy of gas stream in the stack should be less than. So here it is less than the kinetic energy. Third is should be equal to the kinetic energy, and fourth is none of the above. Okay, so Mohammed started with C, then Alka C, Korea C, Rashmi also gave me C answer. So yes, it is obvious that if we are talking about the isokinetic, iso means equal, right? So, and kinetic energy, so kinetic energy should be equal of the gas that is in stack, and also the gas that is through the sampling nozzle. So yes, this should be equal. Then C should be the right answer. Okay, the next is we have some method to measure the level of carbon dioxide in the Gray Wolf multi-gas monitor. So you have to tell me which method do we use to measure the level of the carbon dioxide. So we have four methods: non-destructive infrared spectroscopy, gravimetric method, improved West and Geiger method, modify Jacob and Heuster method. So Abdul gave me A answer, Korea A, Alka A. Anyone? Can I expect more answer from another people? Okay, so yes, A should be the right answer. That is non-dispersive infrared spectroscopy. If we are talking about the gravimetric method, so this is used to measure the particulate matter, right? If we are talking about the improved Western Geiger method, so this is for sulfur dioxide, and the modified Jacob and Hoster method, this is for the nitrogen dioxide. So this non-dispersive infrared spectroscopy is for the measurement of the carbon dioxide. So A should be the right answer. Okay, this is the maximum time interval for monitoring the particulate matter using GRIM EDM 164 model is. So how much should be the maximum time interval that we can select? Mohammed D, Rashmi D, Korea D, Alka 60 minutes D, ASD. Yes. So you people already gave me right answer. So this is 60 minute means the maximum interval that we can select for the monitoring. So that will be the 60 minute. So there is a principle of the method involved in the measurement of the particulate matter in spectrometer of the GRIM model is scattering of light, gravimetric, chemical method, UV photometer. Everyone is so quick to give me the answer, and everyone is today giving me right answer somehow. Anyway, but I'm good that I'm also glad that you are giving me right answer. Alka A, Abdul A, yes A. Yes. So everyone gave me a answer, that is the scattering of light. We will talk about this. So yes, scattering of light. This is the phenomena that we will exploit to measure the particulate matter in the spectrometer of the Grimm model. So yes, A should be the right answer. Scattering of the light. Okay, so I have new assignment questions. So let's talk about this. And my first few questions will be related to the particulate matter 2.5 measurement. So, okay. So, do the NaAQS concentration of the particulate matter 2.5 for industrial, residential, rural, and other area and ecological sensitive area same? Yes, no, maybe yes. So, for example, for 24-hour, it is, uh, for example, it is 40 for the industrial. Is it also 40 for the ecological sensitive area? Okay, Rashmi gave me, let me see. Rashmi A, then Alka, sure. B, B means yes. Okay, Alka, B, sure. Yes. So answer is D, and this is yes. If we will see here, if it is annual, then it is 40-40, and if it is for 24 hours, this is 60-60. So you can say that the value for industrial, residential, rural, and urban, sorry, other areas are equal to the values that is for the ecological sensitive areas, and these areas are being notified by the central government. But you also have to keep in mind that why these values are the same. So reason is that particulate matter, like the reason is only that the sensitivity of your ecological region, the plants or the animals that are in the ecological region, the sensitivity is same as just as in the industrial, residential, or rural or another area. So that's why this value has been kept equal to each other. So this is 40-40 and 60-60. Okay, so because if we are measuring this particulate matter 2.5 concentration, so we will draw the gas from the atmosphere. So what should be the flow rate to draw that gas from the atmosphere to the machine that we have for the measurement of this particulate matter 2.5? So you have to tell me what is that constant volumetric flow rate. So my options are 16.7 liter per minute, 0.0167 liter per minute, 16.7 meter cube per minute, 1.67 meter cube per minute. So what should be the flow rate? Because if you know that if we will have the flow rate and if we will have the mass, then we can calculate the and we have the time. So if we have the time and the flow rate, so we can calculate the volume. Okay, so after that volume, so we can calculate how much gram per meter cube the concentration we have in the atmosphere of that. So that's why we need the flow rate, and that should be constant so that we can calculate volume of our gas or the particulate matter very easily. Even if you are giving me wrong answer, it doesn't matter. But if you are involving, that's enough for me. So you can give me answer whatever you are thinking, right? Okay, so Alka gave me A, Abdul gave me A answer, and AS gave me C answer. Because two-person has given me A answer, so I will go with A. That is 16.7 liter per minute. So you should have the flow rate of 16.7 liter per minute. And if you have the flow rate, as I told you, if you have the flow rate, if you have calculated the time for that duration you did the sampling, then with the flow rate and the time you can calculate the volume. So that's why we need the constant value of this flow rate. Anyway, so we need filter paper, right? And that filter paper is made up of the material that is PTFE, polytetrafluoroethylene, and so that we have the dust or the particulate matter 2.5 on it, right? So we want to know the diameter of that filter paper. So we have four options: 47 mm, 48 mm, 49 mm, and the 50 mm. Okay, so Abdul A, Alka A, Korea A, ASA, Nishant also gave me A answer. Okay, because everyone gave me A answer, so how can I deny with the A answer? So yes, answer is A. So the diameter of that filter paper should be 47 mm. Okay, we will talk about that mechanism and the methodology, how we can measure this particulate matter. But before that, I have few questions. Okay, this is the basic instrument, if you can see. So top of that, there is a inlet, means gas will come through that inlet. Then you have particulate matter 10 impactor. It means only the particulate matter that have the size less than 10 will be entered through this PM10 impactor. Then what will happen? Below that you have the bins, that is the well impactor 96 impactor. So what will happen? That will resist the particulate matter that is greater than 2.5, and then this will allow only the particulate matter that have the size less than 2.5. So we have the filter paper below that, and on that filter paper your particulate matter that is less than 2.5 will be taken place. And after some time we can measure the weight of that filter paper. So this is how we can know what mass we have, what mass has been aggregated after some time. So uh, weighing this filter paper before sampling and after sampling will give you the mass of the particulate matter. And then if you have the flow rate and time, then you can calculate the volume. So if you have mass and the volume, so you can tell the value in microgram per meter cube. So this is the basic principle how you can measure this particulate matter in the atmosphere. Okay, so we are using that filter paper, and the porosity of that filter paper is very much specified. Uh, we are using different kind of filter paper, different material, and because of that, like because of the pore size, that pore size will allow you to the specific particulate matter. So I have, so my question is, while particulate matter 2.5 concentration measurement, 47 mm particulate matter 2.5 is separated and collected on the filter paper over a specified sampling period. What is the pore size of the filter paper? And my option is 2.5, 2.3, 2.1, and 2 micrometer. Alka is changing the answer. Anyway, but I'm good that you changed to the right answer. D, Korea gave me A, Alka right now D, Nishant A, AS A, and Rashmi gave me D answer. Okay. The pore size of the filter paper should be 2 micrometers. So if you are thinking that it is 2.5 because we are having this particulate matter 2.5, then you are wrong. The pore size should be 2 micrometer only. So D is the right answer for this. Anyway, and if we are using that filter paper, we have to do the conditioning in such a way that it may be happen that the gas may have some moisture or even the filter paper have some moisture, so you have to remove that moisture from it, right? So for that, to remove the moisture, to make it very conditioned, so you have to keep it at some temperature, at some relative humidity, and at some constant pressure. So what should be the condition under which you have to keep your filter paper for some time before keeping it into the machine? So this is known as the conditioning. So my question is, to minimize particle volatilization and aerosol liquid water bias, filter paper be equilibrated for how many hours at constant relative humidity of what and at a constant temperature between what? Alka gave me A answer and AS gave me C answer. Abdul A. Okay. So let me give you the hint. We have to keep it for 24 hours. So if you are neglecting the answer B and D, so right now you have answer among A and C only. So try to give me the answer among A and C only. So it is for 24 hours. Korea A. Okay, yes, answer should be A, because we will keep our filter paper for 24 hours at the relative humidity, where relative humidity is 45 plus or minus 5 percentage, and where there is a temperature of 25 plus minus 2 degrees Celsius. So based on that, we can remove the moisture from that filter paper, and if there is some kind of dust on that filter paper, so that can be easily removed if we are doing the conditioning of that filter paper at that such pressure as at such relative humidity and temperature for some time before or the prior to the sampling. So this should be the 24 hours, 45 plus minus 5 percentage of the relative humidity, and 25 plus minus 2 degrees Celsius of the temperature. Uh, okay, so this is kind of the sampling procedure. If you can see, firstly, we talked about that. We are taking the filter paper that have the diameter of the 47 mm, and we have the pore size of it 2 micrometer. So we are having the filter paper that is made up of PTFE, and having the size 2 micrometer. Then what we will do the conditioning of it, and then if there is any hole in that filter paper, so you have to reject it, otherwise that can give you the bias result. And again, on the filter paper you have to note down something like for what reason you are doing that sampling, so you have to label out something on that, so that you can have some idea of which sampling or which area or at what place you are doing that sampling. So you have to note down something. Then so okay, so there was like, first was the procedure. In that procedure, you first have to select the kind of filter that we want for the particulate matter 2.5. Then if we do have the filter, then we have to do the conditioning of the filter paper, right? After doing the conditioning of it, uh, uh, as we already have told about that, how we can do the conditioning, and the purpose is to minimize the liquid water associated with the soluble compound and to minimize the loss of the volatile species. So we have to do the conditioning before and after the sampling. Then Thank you, Alka. Uh, anyway, so let's talk about it right now. So then we will, the fourth step will be, we will weigh this filter paper, because initially we had no dust or no particulate matter on it. After keeping into the machine, we will have some dust on it. And then we have two weights of the filter paper. So we will measure it. We will subtract the weight that we will have after the sampling from the before sampling, so that will give us the mass of our particulate matter, right? And then we will write it down. So this will be the our fourth step. And how we can calculate this? So we can calculate, as I told you, we do have the mass, because we are measuring the weight of our filter paper before and after the sampling. So from where we will get the mass and volume. To calculate the volume, we must have the flow rate and the time. So if we are measuring the flow rate and time, so easily we can calculate the volume. So can you tell me the formula of volume if we have the flow rate and the time? Can you quickly write in the chat box how we can calculate the volume from flow rate and the time? What should be the formula? If we are talking about the flow rate unit, then this will be meter cube per second or per minute. And if it is a time, then this is in minutes. So if you want to calculate the volume using flow rate and the time, what should be the formula for that? Can you guess? We will like, we have two identity. The first is flow rate and the second is time. So either we can divide it or multiply it or subtract it or do the addition of it. So what we will do with these two identity to calculate the volume? If you will divide, so think about that. Uh, the flow rate is in meter cube per second, right? And if you will multiply this meter cube per second by second, then the unit you will get is meter cube per second square. So this is not the unit for the volume. What should you do? And because the unit is different for the flow rate and the time, you can't do the subtraction or the addition because the unit is different. Then what is remaining? It is multiplication, right? So if you have meter cube per second for the volume, and if we will multiply it with the second, then second and second at the numerator and denominator will be cancelled out, and you will have only the meter cube, and that is the unit of the volume. So if you have flow rate and the time, you will multiply it, and so that you can have the value of this volume, right? So if you have volume, if you have mass, then you can tell the particulate matter concentration in the unit, microgram. Gram is for the mass upon meter cube, this is for the volume. So from a meter cube sampling from the atmosphere, how much microgram you are having this particulate matter 2.5. So this is how you can calculate. And this is the flow chart. Like initially you will check the filter paper, then you will mark some identification, then you will do the conditioning. So you will record initial weight of that filter paper, then you will place that filter on the sampler and you will run it for 8 hours or as per your demand, and then you will record the flow rate on hourly basis. After that you will do the average of your flow rate, then you will remove the filter paper, and then what will you do? You will calculate the weight and you will record the total time and the flow rate, and based on that you can calculate the concentration of this particulate matter 2.5. So this is the basically flow rate and basic principle how can we calculate this particulate matter 2.5 using a volume sampler. Okay, anyway, so we talked about this particulate matter 2.5. So let's talk about how we can measure the sulfur dioxide, right? Uh, okay, first you should know what chemical method we are using to calculate the concentration of sulfur dioxide. So I have four options: chemiluminescence continuous analyzer, improved Western Geiger method, non-dispersive infrared spectrophotometer, and modified Jacob and Foster method. So you have to tell me what method do we use for the calculation of sulfur dioxide. Rashmi gave me C answer, Alka B, and Muhammad Abdul Rahim B. Anyone? Sanjeev B answer. Okay, yes. Yes. So the appropriate method for the measurement of the concentration of sulfur dioxide is improved Western Geiger method, and we will talk about it, like what chemicals we need and what chemical will do what, so that we can have the concentration of sulfur dioxide. So we have questions related to that only. So keep in mind that you are using the improved Western Geiger method for the sulfur dioxide measurement. And this is just for just to show you that the sulfur dioxide permissible limit. So this limit is 50 for the industrial ecological sensitive area. This is 20. And if we are talking about 24 hours, then this is 80 and 80. Okay. So just keep in mind that. Okay, so we need absorbing media. So we need some liquid. In that liquid, that sulfur dioxide gas can be absorbed. Okay, so I want to know the chemical name of that absorbing media for the sulfur dioxide. So if you have sulfur dioxide in the atmosphere, you will have some flow rate, and using that flow rate, we will draw the air, and that air will be absorbed in some media. And that media is what? So I have option: potassium tetrachloromercurate, pararosinil then formaldehyde, pararosalinine, and methyl sulfonic acid. Sanjeev C. Okay, with the question mark. Abdul C. Alka A. Rashmi also gave me A answer. So I have two C answer and two A answer. So can anyone break this tie among the C and A? Alka, you already have got it. Okay, Korea gave me A answer. So right now I have majority of A answer in spite of C. So let's see. A is the right answer, that is potassium tetrachloromercurate. So this is the chemical that we will use to absorb the sulfur dioxide gas from the atmosphere to a liquid, right? So this is potassium tetrachloromercurate, and I have written these three chemical reagent as well, and these chemical reagent have some different roles. So we will talk about that only. So just keep in mind, if we are talking about the absorbing media, so then this is the potassium tetrachloromercurate. Okay, so we are using this, as I told you, absorbing media right now is PTM, that is potassium tetrachloromercurate. Why we are using this? It must have some advantages, right? So what are the advantages? So based on the four statement, you have to select the correct statement. So what different advantages we have why we are using this potassium tetrachloromercurate as the absorbing media for the sulfur dioxide? So the fourth statement is that this absorbing media and the sulfur dioxide will form the complex together, and that does not resist oxidation by the oxygen in the air. At the second, that will resist the oxidation by the oxygen in the air, and this complex is stable to strong oxidant such as ozone and nitrogen dioxide, and this complex involve the oxidation through strong oxidation oxidants such as ozone and the NOx. So you have to tell me the correct statement. Why we are using this particular chemical as the absorbing media? Nishan gave me C answer, and this is second and third. Okay. Sanjeev gave me first answer B with the question mark again, and this is one and fourth. Okay, so I'm getting different options. So I want people to give me some, like two students should give me same answer so that I can proceed. Just now I have answer C and B. I want to go with the majority. A is C, second and third. Okay, right now I have a majority for this C in spite of B. Rashmi also gave me answer C. Okay, yes. So right now I have the majority with answer C. So let's see. Answer should be C. Uh, Yes, Sangeeta, answer is C. Why it is C? Because if it is a you know that in the atmosphere with the sulfur dioxide, we have the nitrogen dioxide itself, right? So we have nitrogen dioxide, we have the ozone. So we should have that particular, we should have the media that can particularly absorb the sulfur dioxide and that can resist the interference of other gases. So, and if other gases are nitrogen dioxide and the ozone, and these are because these have the oxygen molecule. So, and so these are known as the strong oxidant. So we need the absorbing media that can resist the oxidation. Okay, otherwise the concentration of the sulfur dioxide will be fade out. Okay, so that's why we should have the complex that will be formed by sulfur dioxide and the absorbing media in such a way that that can resist the oxidation. Okay, and if it is resisting the oxidation, then first and second, among this first and second statement is right. And if we are talking about that resistance, so it means complex is stable. So the answer, the statement second and third should be right, but note the first and fourth. So based on that, C answer should be right. Anyway, so right now you got to know that for the sulfur dioxide, we are using Western Geiger method, the first thing. Secondly, absorbing media is the potassium tetrachloromercurate, so that we can remove the interference of different oxidants. Okay, okay. So we have used one chemical. We do have another chemical as well. But anyway, we will use different chemical to make some complex. Okay, and then that will give you some color. Okay, and that color intensity can be measured by one instrument that is known as the spectrophotometer. But that's you have to set some wavelength of it, right? So what wavelength you have to set to see the intensity of that color that will be given by different reactions. So I have option 510 nanometer, 530 nanometer, 560 nanometer, and the 590 nanometer. Nishan gave me answer C, that is the 560 nanometer, and Rashmi A, 510 nanometer. Again, I need some majority. Mohammed is with Nishant, and he gave me answer C, that is 560 nanometer. Sanjeev C, 560. Okay, so I got the majority for this C, so I think I should go for this. Anyway, yes, I will go with answer C, 560 nanometers. So we use the absorbing media. So another that we will use different chemicals that I will talk in the next slide. So we are using the different chemical that will give you the color, violet color, and that color, the intensity of that color will give you the concentration of sulfur dioxide, that is the proportional to that concentration of sulfur dioxide. And that color will be measured only at the specific wavelength, and that will be 560 nanometer. Okay, so as I told you, in the atmosphere we do have different type of gases such as nitrogen dioxide, ozone, even manganese, and some other gases as well we do have. So to remove the interference of that, we have to add some extra chemicals into our sample unit so that we can remove the interference of that. So for the nitrogen dioxide, what chemical should we use to remove the interference? For the ozone, what chemical or what phenomena? Or for manganese, what should we do to remove this interference so that the calculation of sulfur dioxide concentration becomes easy for us? So what chemical we will use? Sangeeta B, aging, sulfamic acid, and EDTA. What chemical should we use to remove the interference of different type of pollutant that we have in the atmosphere just to measure the concentration of sulfur dioxide? Sanjeev gave me A answer, and Rashmi also gave me A answer. So, and Abdul also gave me A answer. So right now I have some majority for this A. So let's see either majority is going for the right answer or not. Then yes, so for the nitrogen dioxide, we will use the sulfamic acid. For the ozone, just aging means you have to keep your sulfur dioxide mixed in the absorbing media for some time. Okay, so that aging can be happen, and because of aging, ozone can be removed automatically. And for the manganese, you have to use the EDTA. So you will add some drop of EDTA. You will have to add some drop of sulfamic acid to remove the interference of such kind of pollutant that we already have in the atmosphere. So we have sulfamic acid, aging, and the EDTA for nitrogen dioxide, ozone, and the manganese. Okay. Okay. So we already talked about some chemicals, and so let's keep in into the sequence. So right now we have sulfur dioxide in the atmosphere. To trap it into the chemical, so we will use the chemical that is known as the potassium tetrachloromercurate. Then you will keep it into 25 ml volumetric flask. This is not that much important. Then you will add 1 ml of sulfamic acid. Why? To remove the interference of the nitrogen dioxide. Then you will add 2 ml of formaldehyde solution, and this formaldehyde and 2 ml pyrosin alanine solution, and this is for to make some complex, to make some color. Okay, and after that your some color will be generated, and that color will be responsible to give you the concentration of the sulfur dioxide. And then you will take out some sample out of it, and you will go to the spectrophotometer. You have some cuvette into which you will add some sample, and then you will calculate the absorbance. The spectrophotometer will give you the absorbance value, and you have to set that spectrophotometer at 560 nanometer, right? So this is how we can calculate this sulfur dioxide. I do have some, yes, flow chart as well. So we have the absorbing media, and we will use the impinger as well so that we can absorb our sulfur dioxide. Then because we have to draw the air into the sampler. So again, the flow rate we have to keep constant. So we will try to keep the flow rate of our gas to 1 liter per minute for 4 hours, and then we will check the volume at the end of the sampling and we will record it. Then if we have trapped the sulfur dioxide, then we will keep it into some storage bottle. Then not important, this 3 or 4 step, again we will use the sulfamic acid, we will use the formaldehyde, and then 2 ml working PRLA, that is pyroxenyl alanine, and then we will set 0 of the spectrophotometer to the distilled water, and then we will measure this. And using that calibration graph, you can calculate the concentration of this sulfur dioxide, right? So this is the flow chart, how we can use this spectrophotometer and different chemicals to calculate the concentration of the sulfur dioxide. So right now, I think it is clear what chemical we need, what method we are using, and what instrument right now we are using for the measurement of the sulfur dioxide. And yes, for the calculation, we have the formula, and that formula is like the absorbance of the chemical that will have your sulfur dioxide, and one we will capt it as the reagent black, in which there is no sulfur dioxide. So we will calculate the absorbance of that to cuvette in the spectrophotometer. Then we have the calibration factor and the volume of the air sampled. As I told you, we do have the flow rate and the time, so that we can calculate the volume of the air sample, then volume of sample, how much volume we are having, and at last how much volume we are extracting to calculate it into the spectrophotometer, the absorbance. So the volume of alicate taken for the analysis. So this is how we can calculate the concentration of sulfur dioxide in microgram per meter cube. Anyway, so we have talked about sulfur dioxide, we have talked about the particulate matter 2.5. So next is how we can measure the nitrogen dioxide. Okay, so we must know the method, what method we are using, what chemical we are using, at what wavelength we will measure this in the spectrophotometer. So such kind of question again will give you some insight for this nitrogen dioxide. Okay, so which chemical method is appropriate for the nitrogen dioxide measurement? So again, I have the same options: chemiluminescence continuous analyzer, the improved West and Geiger method, non-dispersive infrared spectrophotometer, modified Jacob and Oyster method. So Mohammed Alka Nishant gave me D answer. That is modified Jacob and Oyster method. Any other answers? What method do we use for the measurement of nitrogen dioxide measurement? Rashmi D. Okay, so everyone gave me on the answer D, so I should go for this D answer. So we are using the method that is known as modified Jacob and Oyster method for the measurement of nitrogen dioxide. Okay, again, you should know the permissible level or the limit for the nitrogen dioxide. So this is 40 for the industrial, residential, and rural area, and this is 30 for ecological sensitive area if we are measuring it annually. And if we have the measurement for 24 hours, then this will be 80 for industrial, residential, rural, and other areas. And again, it will be 80 for the ecological sensitive areas. So 40, 30, and 80, 80. So this will be like that. Anyway, so again, we should have some absorbing media for nitrogen dioxide. So for that, we have solution of 2 chemicals. Based on that, we will have the absorbing media. In that, we can collect this nitrogen dioxide. So ambient nitrogen dioxide is collected by the bubbling air through a solution of what and what. So I have option: sodium hydroxide and sodium arsenite, nitrate ion with phosphoric acid, Sulfanilamide and NIDA, and nitrite ion and sodium arsenite. Nishant A, Alka A, Mohammed is little bit confused among A and D. Rashmi A, Tufal B. I do have majority of till now for this A option. Okay, so because we have the majority for A, so I will also go with A answer. That is sodium hydroxide and sodium arsenite. So we will use that two chemical as a solution to collect this nitrogen dioxide in that. And if you know that we have the chemical that is liquid in nature, okay, and we have gas, and that gas we have to collect into our liquid, so we must have some impinger that can increase the collection of the gas into the liquid. So for that we will use some impinger, or the bubbling air. Anyway, so the solution for nitrogen dioxide is sodium hydroxide and sodium arsenite. Again, nitrogen dioxide is determined by colorimetry. Here, the absorbance of highly colored azo dye is taken place at what nm length? So again, you have to tell me, while we are using the spectrophotometer, so what wavelength should we consider for the measurement of the absorbance? I think everyone gave me C answer for that. Let me see. Nishant for 40, that is C, Alka C, Rashmi C, and Mohammed Abdul Rahim C. Okay, yes, C is the right answer. So the wavelength that we will consider in the spectrophotometer to calculate the absorbance is 540 nm. And you have to keep in mind, we are developing some color. And if we are developing some color, then this color will absorb the radiation that we are passing through that cuvette. So how much radiation are being absorbed by that color will give you the concentration of that particular compound, for example sulfur dioxide and nitrogen dioxide. So can you tell me the law of this absorbance and the intensity of color? So what law we are talking about? That intensity of color is directly proportional to the absorbance. More the color we have, more the absorbance we will have. Such kind of law we talked about in I think in physics in 11th 12th class or something like that. Can you tell me the law? Which law do we follow? Okay, my hint is the first word is beer. Can you write in the chat box of like what law I'm talking about, where absorbance and the intensity is related? So whenever you have the more colored intensity, that will give you more absorbance whenever you are passing the light through it, and that will give you the concentration of the sulfur dioxide or some other gases. So there is a relation between color, absorbance, and the concentration. So can you tell me the name of that? And I also gave you the hint, that hint like the law starts with the name beer. Yes, Nishant gave me some answer, and that is right. So this is Beer-Lambert law. You should read about this if you are interested, like how this spectrophotometer works. Okay, so yes, this is known as the Beer-Lambert law that we do exploit to calculate the concentration, right? Anyway, so the answer is 540 nm. Okay, again I have the flow chart, so you have in your mind how we can calculate this nitrogen dioxide. So initially we have the absorbing media. We talked about this. We are using sulfur hydroxide, sodium hydroxide and sodium arsenate as an absorbing media in the impinger. Okay, that impinger will create some air bubble, and because of that, the absorption of your gas will be the efficiency will become higher. Okay, so we are initially using that absorbing media. Then we will connect our gas sampling manifold to gas sampling device, and then we have to draw the air from the atmosphere. So we have to keep our flow rate again to 1 liter per minute for 4 hours, and then we will check the volume at the end of the sampling and record it. And then if again if we have recorded it for the 4 hours, then in the absorbing media right now we have the nitrogen dioxide. So we will store it into the storage bottle and we will preserve it for some other chemical reactions. Okay, then we will take out some aliquot, and then we will add some hydrogen peroxide into that. We will add sulfonylamide into that and nida in that. So we have three more chemicals: hydrogen peroxide, sulfonylamide and the nida. And after adding that, we will get some color, and we will again we will measure the absorbance of that colored chemical into the spectrophotometer at 540 nm, and then we will calculate the concentration using the calibration graph, right? So this is the flow chart how we can measure the concentration of nitrogen dioxide. And again, this is just same like how we calculated using that formula for the sulfur dioxide. So this is again the absorbance of sample, absorbance of reagent blank. So means in that reagent blank, we are not using the nitrogen dioxide into that. And then the volume of air sample, the volume of sample, and the volume that we have taken to measure it into the spectrophotometer. So volume of aliquot, and then some efficiency, sampling efficiency, that is 0.82. So using that formula, you can calculate the nitrogen dioxide concentration. Anyway, so because that particulate matter 2.5 or the sulfur dioxide and the nitrogen dioxide, these were in the atmosphere. We were drawing the air from the atmosphere, and we were trapping that gas into the absorbing media, right? But there is a different case when we want to know what concentration we are having from the chimneys. Okay, so we must have some instrument or some technique or some sensor at the tip of our chimneys or the stack of that chimney, right? So for that, we do use the sampling that is known as the isokinetic, and we already talked about that. Whatever the kinetic the energy we have of the gas in the chimney should be equal to the kinetic energy of that gas at the sampling nozzle. Okay, so we will use that technique isokinetic if we want to know the concentration of our pollutant that is being released from the chimneys. Okay, anyway, so we already know about this, that the sampling at such a rate that the velocity and the direction of the gas entering from the sampling nozzle is just same as that of the gas that we are keeping into the stack at the same sampling point. And again, we already know about that. You also gave me the right answer for that. The kinetic energy of the gas stream in the stack should be equal to the kinetic energy of the gas stream through the sampling nozzle. So you know about that already. So what do you mean by this isokinetic? And here we are using different probes or sensors, you can say, because at that tip of the chimney, you should know the temperature, you should know the flow rate. So for that, we will use the thermocouple or the thermometer. You will use the manometer, so that you can determine the velocity. Okay, and then you will have some another probe. In that probe, there will be and there will also be impinger. So you have the silica gel impinger through which you will absorb that gas into some media, and then using the, if you have the velocity calculation, you can keep it same as the velocity that we have in the stack, and then using the impinger you can absorb that gas, and then you can further calculate it using some chemicals, right? So anyway, so next question is about the indoor air pollutant. So if we have some chemicals or pollutant inside your home, then how we can do measure it? So we have one instrument that is known as the multi-gas monitor. So that my question is, what pollutant is not measured with this device? So, is it sulfur dioxide, carbon monoxide, carbon dioxide, VOCs? So you have to tell me that multi-gas monitor does not measure what type of pollutant. So right now we are talking about the indoor air pollutant. Nishant gave me sulfur dioxide, A. Anyone else? So we have one instrument without using any chemicals that we were using in the laboratory. So we have just one instrument that is known as the multi-gas monitor. So we will keep that instrument in our house so that we can measure some pollutant at our house. So what pollutant we can't measure using that multi-gas monitor? Rashmi A, Abdul B. I will go with the majority, I think. Rashmi, what should be the answer? Okay, Rashmi already gave me A answer. Alka? A maybe. Okay, so yes, go for the majority. So sulfur dioxide is not among the pollutant that we can measure using that multi-gas monitor. Uh, so Yes. So initially, multi-gas monitor used to measure only five parameters that were temperature, relative humidity, then dew point, carbon monoxide, and the carbon dioxide. But we do have different sensors that we can have right now in our multi-gas monitor that can also measure the VOCs, ozone, and even the hydrogen sulfide, that is H2S. But yes, it can't measure right now the sulfur dioxide, so we doesn't have such instrument right now that is very ready to use at the indoor that can measure the sulfur dioxide. So sulfur dioxide should not be among that answer, so A is the right answer. Okay, so carbon dioxide is measured using what type of spectroscopy? Non-dispersive infrared, non-dispersive shortwave, dispersive infrared, and dispersive infrared. These C and D are the same option anyway. I wanted to keep it dispersive shortwave, but anyway. Alka Muhammad gave me A. AS also gave me A. Rashmi A. Nishant A. Yes. Okay, so we have one methodology that is non-dispersive infrared spectroscopy that we do use for this carbon dioxide. And why this is like non-dispersive means we are using the prism or something like that, so that diffusion or the dispersion can't happen. the first thing. Then second, we will use the infrared radiation for the radiations. Okay, and then how much it will absorb or not, so that will decide the concentration of the carbon dioxide. So we have the non-dispersive infrared spectroscopy that will measure the carbon dioxide. So A is the right answer. Okay, so select the true statement for the carbon monoxide. So we can calculate this carbon monoxide using the multi-gas monitor. So you have to tell me what are the different true statements. So I have five statements. The first is CO diffuses in the electrochemical sensor. Diffused CO is oxidized at the sensing electrode. Diffused CO is either oxidized and reduced at the sensing electrode. Current is generated through the internal circuit. The current generated is proportional to the concentration of gas present outside the sensor. So you have to give me the correct answer among these five statements. So what statements is or are right? Nishant, first, second, and fifth. First, second, and fifth. Abdul is also gave me A. First, second, and fifth. No doubt, majority gave me A answer, but let me tell you, A is not among the right answer. This is some kind of hint that I gave you. A's gave me C answer. First, second, fourth, and fifth. Ah, this is little trickier question, I think. Alka, Rashmi, what do you think about that question? Are you able to answer it? Even wrong, I don't care about that. Alka, B or D? B or D? First, third, and fifth. First, third, fourth, and fifth. Yes, Alka. Among that answer only, you will get the right answer. So I again gave you one hint. So Alka gave me two options, and I told that yes, among that options only, there will be right answer. So either from so the answer will be either B or D. That is again one hint. Then you have to tell me now right answer. I'm expecting right answer now. Okay, Alka gave me B answer now. Nishant, what do you think? Abdul, yes, Rashmi, now you can correct yourself. As I told you, only answer will be either B or D. A is B. Okay. Okay, so answer is B. Yes, Nishant, answer is B. Why it is B? It is true that CO will be diffused into the electrochemical sensor, and among electrochemical sensor we have two type of electrode, and among that one is the sensing electrode, right? And at any of the electrode there may be oxidation, and at any another there will be the reduction. So it is not a very typical thing that at the only at the sensing electrode there will be oxidation, but at another electrode as well there may be oxidation, and some another there will be the reduction, right? So just keep in mind that we have two electrode, and it will be determined itself by the carbon monoxide. So at what electrode there will be oxidation, and at another electrode there will be the reduction of it. Okay, then if there is one oxidation and reduction, so the circuit can be completed by the oxidation and reduction, but the current will be given through the external circuit. Okay, so you have some external circuit from where you will give the current. So right now there is a closed circuit, and that the moving electron is here. Okay, and then how much current is generated? So this will be dependent on the concentration of the gas that we have present outside the sensor. So that's why answer first, third, and fifth should be right. So we will use the external circuit for the current, and at any of the electrode there may be oxidation and reduction, and the current that will flow, that will determine how much concentration we have of the carbon monoxide. So this is the basic thing that we do exploit, and we are utilizing right now under this multi-gas monitor, and that's why how we are measuring this carbon monoxide using multi-gas monitor. So this thing can be happen automatically uh, into your multi-gas monitor, because you have such electrodes, and you are giving the power to it. So that's why this carbon monoxide, using some another chemical that we do use in the laboratory, you can just calculate it using the multi-gas monitor. So B is the right answer. So carbon monoxide diffusing in the electrochemical sensor is either oxidized or reduced at the sensing electrode, and coupled with the corresponding counter reaction at the another electrode, and current is generated through the external circuit, and the current generated is proportional to the concentration of gas that is present outside the sensor. Anyway, so because we know that that sensor, or the monitor that we are using, what is the name of that? Mm, so multi-gas monitor. So under that multi-gas monitor we can also measure the relative humidity in our house. Okay, so you have to tell me like how we can uh, how we can know the relative humidity of our home using that instrument. So there are few statements, and you have to tell me the right statement. So this is basically on the principle. So what principle do we use to calculate the relative humidity? So relative humidity is measured by the absorption of moisture by the thin polymeric film. Okay, that polymeric film is under that instrument. The relative humidity is measured by either absorption or desorption of moisture by the thin polymeric film. Then the dielectric property of that film changes as the relative humidity changes. So does the capacitance of the sensor. The dielectric property of the film keeps constant as the RH changes, and so the measurement capacitance of the sensor becomes easy. So you have to tell me the right answer. So this is the basic principle how we can calculate the relative humidity using our instrument. So what firstly, like just keep in mind we are having some film, and that film have some dielectric property. So what different principle of that film and the dielectric property we can exploit to measure this relative humidity? Alka gave me C answer, second and third. ASD, second and fourth. Can you tell me the answer for this? Mohammad Abdul Rahim, A or C? Let me see. Okay, let me give you some hint. Nishant, C, and Alka gave me C, sure. So, okay, so I should go with the Alka because Alka is so sure about answer C. So how can I deny it with that answer? Okay, so answer C is right. Second and third statement is right because if we know that like based on the relative humidity that we have inside our house, uh, like it relative humidity can be absorbed or deabsorbed based on the percentage of relative humidity we have in our atmosphere. If we do not have the relative humidity, then what will happen? If we have more relative humidity, then this will be absorbed. So this will depend on the percentage of relative humidity that we have inside our house, that absorption or deabsorption of moisture will happen or not on this thin polymeric film. So we are using that film, and that film has some dielectric property, and that dielectric property will change as soon as the relative humidity changes. And because this dielectric property is proportional, not proportional, but it is related to the capacitance of the sensor. So based on that property, so we can tell how much percentage of relative humidity we have inside our house. So answer second and third should be right. So C is the right answer. Okay. So, because that instrument can also measure temperature. So, what kind of principle we are adopting to calculate that temperature? So, we have the resistance of some element. Okay, so you have to tell me the name of that element. So, we have some resistance. Based on that resistance, we can measure the temperature of it. So, Nishant gave me platinum and Alka gave me B answer. Again, the platinum. So we are exploiting the property of one chemical, one element, the resistance of that element, and because of that resistance value, we can calculate the temperature. Alka B, Mohammed Abdul B, and Rashmi B. Is it not mercury? We are using mercury in the thermometer. Okay. Anyway, your answer is right. That is platinum. So we are exploiting the property of platinum, and the resistance of platinum with the temperature is very much can give you the very accurate result for this temperature. So yes, we are using the platinum. Okay. Then we use the volume sampler. So we were here talking about the sensor, not body. So platinum. Yes, yes, Alka, you are right. Okay, so we used the volume sampler initially. So we had the instrument, and in that instrument, we were drawing the gas. We had the filter paper, and based on that, we were calculating the particulate matter. So the instrument name was the volume sampler, right? But right now, we can also do the sampling and the analysis of particulate matter using the spectrometer. Okay, so my question, I think one or two questions are left only. So these questions are based on how we can measure the particulate matter using different instrument other than volume sampler that we already talked about initially and in last live session. So, okay, so my question will be how we can measure this particulate matter using spectrometer. And again, this is just to show you that what permissible limit we have for the particulate matter 10 and 2.5. So it is 60, 60, 100, 100. And for the particulate matter 2.5, this is 40, 40 and 60, 60. Just keep in mind that. Okay, this is the spectrometer. So based on that, you will have the question. So in the spectrometer, if you can see here, we have some like here you can see something on the screen. So you have the LCD display, you have some buttons, you have some port. In that port you can connect your wire or you can connect your computer with that, and you have some slot for the data storage card. So that is at the second point. So this is the portable aerosol spectrometer, and this can be used to calculate the particulate matter 2.5 and the 10 micrometer. And here if we can see that here 8 and 9. So 8 is just the filter chamber, and if we can see like again in the volume sampler we were using that filter paper. So right now also we are using the filter paper, and again the same diameter 47 mm and the same material, that is PTFE. So we are using that filter paper to measure, right? And another things that are not that much serious, because we will have the battery, we will have some port, and that port we will connect to the computer so that we can have the some values in our computer. Okay, so here the principle is the light scattering of the single particle. So on the filter paper, we will have the particulate matter. Okay, and here the principle is that by that particulate matter, there will be the scattering of the light. So we will give some light to the particle, and based on that, there will be the scattering of light. So this is the basic principle that we will use in the spectrometer. So my question is, the measuring principle of the model is the light scattering of the single particle with a semiconductor laser as light source. The detector is positioned in the dash angle to the incident laser beam. So for example, your laser beam at in the horizontal direction, and you have the particles. So the detector that will detect the scattering of the light. So at what angle that detector will be? So I have option 0 degree, 60 degree, 90 degree, and 180 degree. And I saw that some of them you already have given me some answer. Nishant 90. Korea C, that is 90, and Muhammad Abdul Rahim also gave me C answer. Alka, what's your answer? Alka Rashmi. Okay, Alka is also with C. Rashmi, are you here? Korea? Okay, Korea already given me C answer. Yes, I saw that you already gave me C. Rashmi also gave me C. So yes, this is 90 degree. So if we, okay, so this is the 90 degree. At that position, at the 90 degree, we have the detector that will detect the scattering of light, and based on that, that will give you the concentration of your particulate matter. Okay. Now, as I show you that spectrometer, and that spectrometer have some port, that port will be connected to the computer so that you can select the time interval. For what time interval you can measure the particulate matter. So what is the minimum time interval and what is the maximum time interval? So the A answer is 6 and 60. The B is 3 and 30, and then 5 and 60, 5 and 30. I think this is the last question. Okay, Rashmi gave me A, very quick, and Nishant A, Korea A. Abdul A. 6 and 60. Alka, me also responded already. Oh, is it? Let me see. Yes. Yes, okay, above Rashmi, you already have given me answer A. Anyway, so all of you have given me answer A. So yes, I will go with answer A. So we have some options and option of like how much time interval we can have. So each 5 second or each 5 second or each 5 minute you may have data. So based on that, you can select the time interval. So this is how like we can select the time interval. It is from 6 seconds, then 1 minute, 5 minute, 10 minute, 15, 30, and 1 hour. So up to 1 hour we can select our time interval. I think that was all for this. Okay, this is same. Okay, thank you. Thank you for being patient. And right now, I don't have more question because I think even instructor also had some uh, 20 or 30 minute 30-minute presentation. So I think the syllabus was so like not that much abroad. So I thought that answer should like MCQs should be short for that. Anyway, so right now 12 weeks has been over, and I will have one extra class tomorrow from 6 to 8 only. So if you people think that you are having some difficulty at some particular topic, so you can tell me even right now, and you can tell me on my email by 8 or 9 p.m. today only, so that I can give you some insight about that particular topic if you are having some difficulty into that. Alka, please change time from for tomorrow's. I can't change the time, Alka, because I already have given the time, and because I also need some time to prepare the slides. So I thought that I should work today in my laboratory, and tomorrow only I will prepare the slides. So I need some hours to prepare the slide. That's why I chose the slot only from 6 to 8, and this has been fixed, so I can't change. Can you share us all week assignment question in PDF form? Yes, I can provide it. Right now, I have uploaded every assignment question into this slide only. But yes, I can make the PDF and can share you. Yes, Karya. Rashmi, I can't start with 4 because time has been fixed already, and this time has given to the NPTEL, so I have to start it by 6 only. How to manipulate 12 weeks lecture for exam? I couldn't understand your question, Abdul. Thank you, Karya. Do we have only MCQ or should we accept? I think we got a mail in which it was, no, I think there was some long type question as well. Was it only MCQ? Let me check. Give me 1 minute. Let me check. 1 minute. I'm searching for that because give me 1 minute. There was some instruction about your exam. So I think you got the mail about the exam format. Okay, so should I share? Yes. Let me stop this and so can you see that? Here it was written that the type of question may include MCQ, filling the blanks, and essay type answers. So if it is essay type answer, then I don't think that only MCQs will be here. So I don't know, but if Alka is sure about that, because I don't know about this NPTEL like exam format or not. But yes, I think you also got that mail, and I also. So here it is written that type of question may include MCQs, filling the blanks, and essay type answer. So I don't know, like if it is written like essay type answer, then it can be long answer, or like you can write something. So I don't know. Alka, how you are sure about that? That only MCQs question will be asked, because here it is written the like
एक्चुअली
essay type
मैं
answer.
पहले भी दे चुकी हूँ एक बार, क्योंकि मुझे कॉलेज 4 क्रेडिट देने, चार चार कोर्स करने हैं मुझे, तो 4 कोर्स क्रेडिट देने हैं, तो 2 ऑलरेडी होगी, इसलिए मैं मुझे पता है कि 2 एमसीक्यू थे केवल।
Okay, okay. So you already have given the exam for two another NPTEL courses, and based on that, you are inferring that because that
और मे बी
exam.
6 or 3 fill in the blanks, 1 or 2 course only.
Okay, so Alka is telling based on the inference, because she already have given two exam of the NPTEL, and that was based on the MCQs.
Not 2,
So
only 1.
okay, okay, only one. And so so I don't think, but right now it is written that it can be MCQs, filling the blanks, and the essay type answer. So from there, I can infer that they can also give you some long type answer. But yes, if Alka has some experience, that you can also rely on her. Korea, you wanted to speak something? You raised your
यस
hand.
मैम, एनपीटीईएल की जो गाइडलाइन है ना, उसमें जनरल फॉर्मूला सब एग्जाम के दिए, किस किस के फॉर्मेट में कौन कौन से एग्जाम होगी, तो उसमें ये कोर्स की एमसीक्यू टाइप की फॉर्मेट दी हुई है,
Okay, okay.
ओनली
Should I
एमसीक्यू।
go to? Okay, should I go to that click wala cheez? Click here. Is there any information about that? Okay, okay. So can you tell me the name of that course? Yes. Okay, so it is online and computer based. So okay, so right now it is confirmed that it will be only online and computer based, means MCQs and only like filling the blanks they can ask. Yes, now it is clear. It's okay, Rashmi, if you are unable to join tomorrow at 6 a.m. because I have an it's I don't mind about that, but yes, my class will be only from 6 to 8, and if you are free, you can come and join. But if you are not free, then it's all right. You can work here. Yes. Okay, so keep in mind that there will be only MCQs question, because we already have seen. I didn't. Okay, okay. Let me. Okay, I didn't show you that. I opened it right now. Okay, so here if you people can see, can you see here? Then this will be only online or the computer based air pollution and control. Some exams may be offline and will have the pen and paper. So, but this course air pollution and control will be only online computer based. So yes, only MCQs and filling the blanks they can ask, but they will not ask you the essay type question. Thank you, Korea, for giving me this insight. Okay, if any another question you have, you can tell me. Otherwise, you can use Korea. I will send you the PDF in mail. I can also upload this PDF into that folder that I already have shared you. And if you have any another difficulty that you want me to teach you about that, then you can send me the topic of that, or the particular terminology, so that I can give you the lecture on that tomorrow. And tomorrow will be the last class from 6 to 8. Also, I request you to please join, because this is not the Monday, this is the Tuesday. But anyway, so you can come and join. Otherwise, I will see what things I can add into that slide. Okay, so you can leave. Thank you, Nishant. You will join. Okay, I will welcome you. Anyway, so you can leave if you do not have any problem. Thank you, Korea. I initially thought that this Korea is the male name, so I had in my picture that you are a boy, but today with your voice I got to know that you are a girl, and your voice is sweet. Anyway, thank you so much. I'm just leaving this call. Okay, your name is Krupali. Okay, Krupali.